Molecules exist in three dimensions, and the three-dimensional structure is really important for chemists to understand because the structure of molecules impacts their chemical reactivity and their physical properties. So a simple way that we can predict the three-dimensional geometry of a molecule is through this VSPER theory, which stands for valence shell electron pair repulsion theory. And basically what this means is that the valence electron pairs around a central atom, so the bonding electrons, the lone pair electrons, are going to repel one another and orient to be as far apart from one another as possible. So based on that, we can predict the geometry. So let's consider carbon. We know that it's common in biological molecules, and its most common uh, way that it shows up is with four covalent bonds. We've already seen that its two-dimensional structure makes it look like the distance between the bond angles is 90 degrees. However, these electrons in the bonds repel one another, and if they extend into three dimensions, they can be even farther from one another. And so they do. Now, anytime a central atom has four electron pairs around it, doesn't matter whether they're lone pair or bonding, anytime a central atom has four valence electron pairs around it, those electron pairs are going to orient to be as far apart as possible, and the way that they do that is through bond angles of 109.5 degrees. So carbon typically has four single bonds around it, and those single bonds will orient in angles of 109.5. Now, if we look at this ball and stick, we can clearly see the three-dimensional nature of the carbon in those four bonds. But it's not always convenient to write a ball and stick model. So we have another model to show the three-dimensional nature of carbon when there are four valence electron pairs around that carbon, which happens quite a bit. And that is known as the wedge and dash model. So the way the wedge and dash model works is the solid lines indicate bonds that are in the plane of the paper or the screen. So if we look at this ball and stick model, that would be these two bonds, okay, in the plane. The wedge represents a bond coming towards you from the screen. So that would be the wedge right here on this ball and stick. And the dash represents the bond behind the plane of the paper or the screen, which would be this. So anytime we see this, we know that the wedge is the bond coming towards us, the dash bond away from us, and the solid line are the two bonds that are in the plane of the paper, and all the bond angles are 109.5.